Hello everyone, the topic of discussion of this video is SSTI. In May, I went to B-Sides Budapest. It was an awesome one-day event about all things cybersecurity. There, I actually participated in a CTF, and one of the challenges was based on SSTI. So I thought it would be a good idea to use that as an example and introduce SSTI to everyone. SSTI stands for Server-Side Template Injection. We'll talk about its history, how to identify SSTI, exploiting the SSTI, and finally how to mitigate it. Let's start with the history. In ancient times, when humanity discovered internet and they wanted to host their websites, they used HTML. The static HTML was used to create web pages which would be hosted on servers and everyone could visit them. However, this method was inefficient for creating dynamic content. So in order to add dynamic content, server-side scripting languages like Perl and PHP emerged, enabling developers to embed server-side code within the HTML. This allowed for more complex and dynamic web applications. As web applications grew in complexity, mixing code with HTML became a pain, since the developer not only has to take care of how the website looks, but also the application logic behind it. Enter templating engines. So at this point, you might be asking, what is a templating engine? Well, templating engines separate application logic from presentation logic. Let me show you how. Let's say you made a social media website. You want a registered user to be greeted with his or her name as soon as he logs in to your social media website. You want experience for all the users who log in to look the same, even if there are frequent changes in the visual components. Templating engines use placeholder or tags, depending on which engine you use, to denote dynamic content. These placeholders are replaced with actual values during the rendering process. This, by the way, is an example of Jinja, specifically Jinja 2, which is a Python-based templating engine, which also was the one in the challenge I solved. Jinja is just one templating engine. There are many other templating engines that can be used in order to improve maintainability and generate content dynamically, so the developers can focus on the core functionality and spend less time in streamlining user experience. So now you know what templating engines are. Let's talk about the vulnerability that occurs from these templating engines. Server-side template injection occurs when user input is embedded in server-side templates without proper sanitization or validation. Because of numerous templating engines, the vulnerability is quite widespread and is often found in the wild. It basically has its own category, so it is a big deal. The impact of an SSTI can range from an information disclosure and local file inclusion to a full-blown remote code execution. So at this point, you might be thinking, these templating engines exist for quite some time now. So, since we have all these fuzzing tools, there shouldn't be any such issues in those templating engines. Well, no. Here are some case studies as recent as May 2024. The one that I found the most interesting was the Crush FTP SSTI. The CVE 2024-4040 has a CVSS score of 10.0 and has been reported to be exploited in the wild by CISA. CVSS 10.0 is the highest CVSS score possible, and the number of instances exposed to this vulnerability is insane. I will add the link to this awesome blog post by Sonic Wall along with the other resources in the description below. So with that theory out of the way, let's see how you can identify server-side template injections. Let's look at some code. I would highly recommend following along with me while watching this video. In order to do that, first you need to go to this GitHub repository, the link of which is also in the description. Let me quickly clone it. So I'm going to copy the URL and open a new terminal here. Go to the desired location where I want and simply clone the repo. As you can see, I have the repo cloned. So let me open Visual Studio Code, or let me clear this. Let me open Codium, which I have installed so that I could show you the code, and let me open the folder. Before we start looking at the code, in order for this code to work, you need to install 3 Python dependencies, which you can go and do by simply going to a new terminal. And since you would have pip installed, simply run the following commands to install Ginger2, Flask, and markup safe. So pip install, and I think it's, in my case, it's pip3 install Ginger2, markup safe, and Flask. Great, all 3 of them are installed. Let me clear this. Now we'll go to CLI and go to identification. Now if you look at the code, what we are doing is we are importing template from Ginger2, taking user inputs, creating a template with the value welcome with our username, and then finally printing it out. Let's see this in action. So let me run the command. I'll do it simply by using Python 3, CLI, identification.py. It asks me to add my user. I'll write name elastic, if I could type it right. And it shows me on the CLI welcome name elastic. Now let's try to run this as an app. If you'll see here, I have a Flask app here. So let me try and run it. It will run on port 5000 and would allow any IP address to run it. So you can run this code on a server as well. However, be mindful that this is a vulnerable app, and if it's exposed to the internet, everyone would be able to hack it the same way I'm teaching here. So be careful and use it only for learning purposes. Alright, so I'm going to run this by using Python app 3 app.py, and I can simply access it via this link. I think I made a mistake. So let me quickly copy this and paste it here. Awesome. This is my website. Let me write again the name, and it does the same thing. If you'll see the code, you can simply see that I'm doing the same thing. I'm taking a request form. First, I put the default as guest. I take the get method with the username, and then I render that username here. And you might notice that this is similar to the CLI that we saw here. Same way it's taking the input. Let me open this also in a new tab. So they are basically the same thing being rendered from the template. Great. Let me quickly stop this. Clear. And let's go back here. Alright, so if I run this, I could write any name here and this would render. But what if I write a digit? So let's say 7. Yeah, 7 also renders here. And if I try to write 7 into 7, this also renders. Welcome 7 into 7. Or if we check the app.py, I'm using the template and rendering it via these values. So let's try to use the same templating syntax here. And now, if I write 7 into 7, you'll see it gives me 49. If you look closely, I'm doing the multiplication of two numbers. But what if you multiply a number, either integer or float, with a string in Python? Let's see if I do this with this. Essentially what I'm doing is I'm using 7, multiplying it to the 7 string, and it should give me 7 sevens, which is how string works in Python. Let me try that again. I think I did not start the, alright. And you can see It does the same thing, which means it's actually running Python code. Let me go further and just show you. This is simple Python. You don't need to try it, but you can. If I do this, if I do this, you see it prints t 7 times, just like how a Python interpreter would work. Let me clear this. And now let's try this on our app. So let me run this again. I can simply type this Python 3 app.py. It's running on port 5000 again. Let me open it, refresh the page. Yes, I'm going to resend. And now let's run the same payload. So 7 to 7. And you see the same Python code is being worked. And just to test it, I'm gonna make it in quotes. And it's actually running Python code. And instead of the template just showing my name input, I was able to bypass it and I'm running Python code. But unlike a usual Python code, I cannot import anything directly here, because that would not work. So if you think I can do this, let's say requests, that won't work. It simply gives me an error. So how can I use it in order to exploit it and do something meaningful from it? Please understand, it's very important that once you have a vulnerability, you need to have valid exploit that shows some impact. Without impact, vulnerabilities are often prioritized lower, and it's a hard sell for developers to fix them. Okay, so we identified that there's an issue. I can print those weird 7s. What else can we do with it? So let's start from scratch and add our Jinja 2 template syntax, indicating that the content inside should be evaluated. Now if we go to the code, this is app.py and we see it's actually getting a request which it imports. So what happens if I run this? Let me try and write request here. And it prints out this weird thing. If I simply open a new terminal and then type Python and then import, let's say, requests. This is not the request that we had, but simply the module requests. And then if I simply print this requests, you see it's kind of in a similar form. Basically, it's an object that we are printing. In our case, we were actually able to print object that's being used. Okay, so we got the request. What else can we do with it? In Python, another thing that we could do after adding request, we can actually get the class of this request object by simply using class. The next thing that we could do is use init to initialize a new object by using the initializer method of the class. Then we can simply use the globals to access the global namespace of the initializer method. And then we can simply select built-ins from the array. By using this. And then in those built-ins, we can use import and then finally import whatever we want. So in this case, we'll use OS, which is something that is available as a module to all Python interpreters. Let me quickly show you what I did. So I copy it and open a new form. And you see I use request, went to the class, initializer method, check the globals, from global selected built-ins, then import, and then imported OS. This whole thing from here to here is similar to me running import OS. And now what I can do is I can go further and modify this payload to do what I want. So in this case, I will use popen, which would open a process, and then write whatever command I want. So here, whatever command I want, and then .read. Essentially, I use this to import OS, and use this to give it a command, and then whatever command I want, I could write here, and it will read the output, essentially making it a remote code execution. Let's try this. Let me make this command as ls. Let me copy it. And let me try to paste it here. And as you can see, it's showing me the values of all the files that were here. Let's quickly check them. Let me stop this, clear it, and if I press ls, you can see these are the same files that we see here. Essentially, by using this payload, I was able to perform a command execution. So here we use ls command, but in a real scenario, if you find a vulnerable website, instead of this ls command, use something more malicious to have direct connections, create havoc on the entire system. Let me stop it now. The payload you saw might have been a bit intimidating, but believe me, once you know the basics of a certain language, it becomes really easy. For my case, when I was doing the CTF, of course, as soon as I found it was Jinja 2, I went to this awesome payload repository called payload all the things, as you can see here. And when I was doing the actual CTF, I opened it. It was called B-Sides Badge Creator. I would go to the website and then find out, oh, it's using Jinja 2. Immediately, I'll go here. Of course, because I cannot remember all the inbuilt functions, so would simply go to server-side template injections, and then check out the languages, which in my case was Python and Jinja 2. Once you go here, you could see these are the basic injections, which we also tried. This is simply a format, but if you'll go a little further, you can see how you could access globals and built-ins. And then finally, from accessing a remote file to having a remote code execution by doing a netcat reverse shell, and finally running the commands how we did. This is a really good resource that I would recommend everyone to check out. I will link to this in the description. Apart from Python, you can also see there are many other languages and templates that can be found in this repo. And overall, this is a pretty good repository that could give you payloads for all sorts of vulnerabilities. Apart from payload all the things, there are also a bunch of other resources that are very helpful for server-side template injection. I will add a link to all of them in the description. There are also a bunch of tools like Jinja, SSTI map, TPL map, apart from the regular proxies like burp and zap that you can also use in identifying and exploiting server-side template injections. With that, now until this section of the video, we have covered history, identification, and exploitation. Now let's move on to mitigation. If you remember, in our identification code, if I go to terminal, I was able to run the payload by simply running the identification.py and then adding this payload. So as a developer, the first thing I need to do in order to mitigate this issue is by simply adding proper Jinja template placeholders in the code so that it minimizes the chances of a user adding their own input. We can do that by simply, instead of doing this, we add our template here. And let me put it here. Now, since already it's templated, the user cannot provide the same input. Let me save it and show you how it's fixing the issue. And we forgot the double quotes, so let me add them. Save them, run it again. And now if I use the same payload, it won't work. It's simply outputting the same string. So simply adding the template mitigated some of the issues. This solution you can also find in the mitigation.py file for the CLI. Now let's look at our app.py file. If I open it, and let me clear this. And now if I'll run it directly, this would be used by taking inputs directly from the user. So in order to fix this, similar to how we did in identification.py, I need to change this to the Jinja2 placeholder. And since, if you'll go up, I'm using f, which is the Python f string, instead of 2 here, I would need to add 4 of these codes. And this is simply because one is just for the username replacement, and the other 3, along with this 4th one, would translate into how we added the placeholder here. So finally, when it comes out, it should have these 2 placeholders supporting username in the Jinja template 2 format. So let me quickly add them. And one more. All right. And I will run this again now. So we have our username here. If you go up, we have request form.get username. So I'll just save it and quickly try to run it. So Python 3 app.py, and it's running. Let me open my browser, and it's open. Let's go to localhost 5000. And now if I use this payload, it gives me the right values instead of giving me how it was showing it earlier when I'll put 7 cross 7, it used to be 49. Now while we added this placeholder so that users cannot bypass the template and cause template injection, I would still consider this as half measure, because there are still ways how a user could bypass this template by simply adding comments and whatnot. In order to make this really clean and avoid exploitation, what I can do is simply make it markup safe. So even if attacker tries to hack it using special characters, those would be properly sanitized by the markup safe functions. If you don't know, markup safe is a Python module that helps you to escape all the special characters. Here I have it already imported from markup safe import escape, and I'll use that escape to basically escape all the characters provided by the user. So it's never considered as a template or placeholder of the Jinja2 template. Obviously, I added it. If you don't have it, you need to add it. And just like how we are using it in Python, there are different ways of making templates safer for different languages by either escaping the characters or using different other sanitizations that could help you avoid exploitation. So let's use this one. I would simply use the escape function. So the entire thing that we are getting from the user, I'll simply put an escape and then retrieve the information. Now this code not only has template placeholders, but it also has an escape function that will make sure all the inputs that are provided by the user are sanitized. Let's test it out again. So if we go back to our app, let's go back here. Let's write request. And as you can see, it's just rendering it as is. I could put any payload and it will not work. So we saw in our live example how you could mitigate a server-side template injection issue. But what other mitigation strategies one can use in order to avoid server-side template injection? So apart from all the scanning that every organization is doing, including the static application security testing, dynamic application security testing, and software composition analysis, you should also take care of these 4 major points in order to avoid server-side template injection. First and foremost, input sanitization and validation. You should always properly sanitize and validate all user inputs before rendering the template to prevent code injection. Then, on number 2, always follow secure coding practices. Following secure coding guidelines such as using the principle of least privilege and avoiding unsafe template rendering functions greatly reduces the chances of SSTI. Number 3 would be using up-to-date and patch version of template engines. Although these would be covered in software composition analysis, Sometimes your SCA tools are really slow and a patch would be out earlier than your SCA tool telling you what vulnerabilities in the open source libraries have occurred. Basically, keep the template engines and related dependencies up to date to ensure that known vulnerabilities are patched. And finally, another complementary approach is to accept that arbitrary code execution is all but inevitable and apply your own sandboxing by deploying your template environment in a locked down Docker container, for example. You should always consider that your software would eventually be hacked, and once it is, you need to make sure you contain the blast radius. Like I mentioned earlier, you can do it by having a sandbox environment in a lockdown container or have network objects which are isolated and all such networking strategies that you could use in order to make sure that in case of eventual exploitation, the impact is as low as possible. I hope everyone now knows what SSTI is. I will share all the data, including the vulnerable app that you can run locally and PDF document with all the resources for further reading so that you can rewatch this video and understand all the concepts better. Thank you. I hope you enjoyed the video and have learned something new. I'll see you in the next one.